Hello friend, today we're going to learn how we can find a day of a given day. So in such type of quantitative aptitude problem, we get date like 28, 12, 1989, and what will be the day. Either it will be Sunday or Monday, Tuesday, you have to tell that. So to solve this type of problem, we need to look at very basic thing, how dates actually work. So now very first thing we should need to know is 1 year we consider number of days is 365, and in leap year we consider 366. But in actual terms, the total number of days in a year are 365.24189, something like that. So now as you can see, which means if you multiply it by 100 year, 365.24189 into 100, we will get around 24 leap years. So in 100 years we have 24 leap year, but what we left is this 0.00189 parity. So somewhere in the century we will have a leap year which is century. So that number is actually 400. So if a year is divided by 4, that year is leap year unless this year is a century year like 100, 200, 300. But if the year is also divided by 400, like year 400, year 2000, year 800, then this year will be leap year. So this is the basic information we need to keep in our mind. We're going to use it later. Now what we're going to do, the very first thing is we're going to create some small table, and it will be easy to remember because it's just mapping of days to a number. So let's say we have Sunday. Everything starts from Sunday, so we denote it with 0. Then Monday, we denote it as 1. Then Tuesday, denote it as 2. Then Wednesday, if we denote it by 3. Then Thursday, we denote it by 4. And Friday, denote by 5. And Saturday, denote by 6. So this is something we keep in our mind. It's just every day is represented by a number. Now the second thing we need to remember is another table. So if, let's say, if a number is completely divided by 7, that means that day is we consider as the first day or whatever point we start. So let's say Tuesday was at 7, so next Tuesday will be at 14th, next Tuesday will be at 28th. So all the relation with modular 7. So what we're going to do, for every date in a month we're going to evaluate how many extra days after modularing it by 7. So whatever we get after dividing it by 7 remainder, how much we left with. So in January, because January is 31 days, so 31 modular 7, that means 7 for the 28, so it left with 3. In Feb, if we have leap year is 29, that means left 1, otherwise left 0 because 28 is divided by 7. Same as March is 31, that means 3. April is 30 days, that means 2. May is 3. June is 2. July is 3, August is 3, September is 2, October is 3, November is 2, and December is 3. So we're going to remember this because all we want to do is we want to calculate what remains after 7 anytime we try to calculate the days. It's just a magic formula. Just keep this in head and we're going to use it, then we're going to explain it how it works. Now, third and most important thing is we're going to calculate what will be remainder for 100 year, 200 year, 300 year, 400 year, and then we're going to make a generic formula for remaining year. So for 100 year we already know there are 24 leap years. So now second thing we want to know, because in normal year there is a 365 days, if we model it by 7 we get 1. Okay, but for leap year is 366, we model it by 7 we get 2. So for 100 year we get 100 minus 24 normal year plus 24 into 2, this much extra we get. So for 100 year how much extra we get is actually 124 if we sum it. So now if we divide 124 modular 7, 7 1 is 7, 7 3, 7 1 is 7, 8 9 10 11 12 5, and I just divide it 124. I cannot do it in my head. 7 1 is 7, that leaves us 3 to 5 plus 4, 7 7 to 49, that leaves us 5. So for 100 year our parity is 5, so we put it here 5. For 200 year is basically 100 year plus 100 year, so what will be remainder? 5 plus 5, that is 10. Now 10 is greater than 7, so we again model it by 7, that gives us 3. Now 300 year is basically 300 plus 200 plus 100, that means 5 plus 3, that gives us 8, and when 8 modular 7, that gives us 1. Now in 400 year we know already there is a 1 extra leap year, so we will have 1 extra date added to it. That's what we calculated here. So 400 is basically 300 plus hundreds plus 1. So 300 is 1, 100 is 5, and plus 1, that is 5 plus 1, that gives us 0. So now when we come to 500, we basically have 400 plus 100, and because 400 already gives 0, so 500 will relate to 100. Similarly 600 will relate to 200, 700 relate to 300, and 400 relate to 800 relate to 400. So this sequence will keep going 5 3 1 0 5 3 1 0. Now this much information we have. Now let's try to utilize this information to solve a date. So let's say I have the date 8/4/2021. Okay, so for date 8/4/2021, first thing what we're going to do is we're going to get 31/12/2020. We're going to evaluate what will we did there, and from there we're going to evaluate months and all. So for 2020 we can basically modulus it by 400, so it will give us 20 plus 2000, which is actually divided by 400. We already know anything which is divided by 400 will result always at 0. So now our dedicated number is 20. So we have 20 year. In 20 year, how many leap year we have? 20 divided by 4, 25. 5 leap year. So that means we have total number of year or total number of extra days 20 minus 5 into 1 plus 5 leap year into 2. That gives us 25. Okay, now we reach until 31/12/2020. Now for remaining 4 months, so 4 months is basically we need to calculate Jan, Feb and March, and because we're already in April, we don't need to calculate extra year because we already know there are only 8 days and we calculate is straightforward directly. So just let me clear the board to go ahead and calculate. So we already know it has April have 8 extra days plus we calculate until 31/12/2020 we have 25 extra days plus we already created a list for Jan, Feb, March because there is no leap year. 2021 does not have leap year because it's not divided by 4 and it's not a century. So it has 0, January has 3, Feb, March has 3. So now we add plus 3 plus 3. What gives us 336 plus 8 is 14, 25 plus 14 that gives us 459 and 3, and we more or less is by 7 we get 4. Now we already created a list. 4 is Thursday, so our day is Thursday. Now similarly, let's try to calculate one more random year. Let's say is 10 8 1828. Okay, now for 1828 we modulus it by 400. What we get? 1600 plus 228. Until 1600 everything is 0, forget it. Now we have 228. Now we already calculated for 200 is 3. The extra days are 3. So we're gonna go ahead and make 200 extra days 3 plus we have 28. Now as you can see 28 is the last year which is a leap year. So what we need to calculate until 27 year because 31/12 and the year passed. So for because it's 2028 we're going to calculate 31/12/1827. So now we have 27 years. We modulus it by 4. What we get? 6. So we have 6 leap years. So 27 plus 6. Now why I added that is basically I calculate 27 one time plus I added one extra for 6 leap years. So that directly gives us this. So you don't have to do plus minus. And is 3 and 3, 33. We get 33. So we have 33 for these many year, and for first 200 year we have 3. And now what else need to calculate is 8 2028. So for 8, so we need to calculate complete 7 month and one last month. What is the day? 10. So we need to calculate 7 days and plus we need to add 10. So we just need what is this 7 days, what is this x. So this 7 months. So for 7 months we going to go our table. 3 2028 is a leap year 1. So 3 plus 1 plus 3 plus 2 plus 3, 1, 2, 3, 4, 5, 6, 7, 8 plus 2 plus 3 plus 3. So yeah, only for 7, not 8, because we need to add only for 7 because 8 is our actual date. So 3 plus 1 4 plus 3 7 plus 2 9 plus 3 12 plus 2 14 plus 3 17. So total 17. So our x is, right, it's 17. So now we sum everything. 33 plus 3 plus 17 plus 10. Well, it gives us 3 plus 3 36. 36 plus 10 is 46 plus 17 is 3 4 1 5 1 6 63. Now we can see 63 is divisible by 7 9 times. That means our modular is 0. That means that day is Sunday. And that is our answer. Simple as that. Now if you practice it, you can do it less than 1 minute. And see you until next video. Bye bye.